Our fourth experiment is about the maximum power point. So we do have a solar panel here and a programmable resistor board. So what we do is we want to find out what load is the best to get the maximum out of this solar cell. Therefore, we need to know how to conduct an experiment. We need a controlled condition. Therefore, we do have this artificial sun here. Now it's shining, you can see it. It's light. And this gives us always the same light if we do our measurement, because if we do it outside or just by daylight, a cloud might come before the sun, the light changes, and so does the solar panel change, and the maximum power point also changes, and that is what you can figure out with this experiment. So the main idea is you position this solar panel in a specific angle to the sun, artificial sun. It doesn't has to be 90 degrees, so the best angle. It can also lie here on the table. And then we start putting different resistors as a load, and we're measuring the output. It's enough if we measure either voltage or current, because we do have the resistor value and we do have the measurement we're taking, meaning voltage or current, and therefore we can calculate what is the output power of the PV panel. If we have collected all the data we need, meaning the output power of the PV panel and our resistance, then we can evaluate these data and come up with a final graph to display our results. So we have a y-axis and the x-axis, and on the y-axis we do have the power, so the output power of our PV panel, and on the x-axis we do have our resistance of our programmable resistor board. So if we put the data into the graph, it should look like this, like a bell. And then we can see, okay, here's the maximum point. So we can see, okay, at what resistance did we have the maximum outcome of our PV panel. And the interesting thing is, if we do change the light now, for example, the sun turns a bit because it gets noon, and we do the same measurements again, this curve should shift a bit. And maybe it looks like this now. It's not as high as the previous curve because the sun is not totally shining onto the PV panel. There's most of the sun going besides it. So it's not as high, and because the light has changed, the maximum power point also shifts. Now we can see the maximum power point is somewhere here, which is at a different resistance. And that is what we want to find out and what we want to clarify with our learners here. That if you do put a solar panel, a PV panel, onto your rooftop, you need some electronic controller which is constantly checking what is the light condition outside, shining, the sun or reflected light shining onto the PV panel, and how do I need to change my load resistance so that I get the maximum out of this PV panel. And this is probably one of our cheapest experiments. You only need the PV panel and the programmable load resistor board, which costs around 10 euros, which is around 200 South African rand, and the solar panel the same. So in total you are with 20 euros roundabout and 400 South African rand. And of course you need a multimeter. I hope most of you will have one in the electrical workshop. If not, you would have to purchase one of these as well. But what I also wanted to show you, we do have another experiment, and if you want to check out which experiments we all have, please go to our playlist. You'll find it in the description below. Also the link to all the material we used, we provided there on the University of Stuttgart's website for you. But this experiment was also explained in a different video because we can figure out some other points with this one as well. But what I wanted to show you is that this maximum power point is already implemented in this setup as well, because here we have a changeable resistor. So let's check out. If we take again our Phyphox app. Okay, so now we are back in our Phyphox app, and when I do place now the solar panel here into the sun, I hope you can see everything, and we play the we press the play button. Now it starts recording the value, and now if I'm shifting this resistor here, as I said, we have a nice curve measuring here. And now I press the stop button, and now if we maximize this, we can clearly see this curve. It doesn't look like a bell like I draw it here on the whiteboard, but we can clearly see the maximum power point is around. Now the angle is difficult to see, but can't we measure also? Pick a data. Here we can pick a data point on the app, and so we see, okay, with 620 ohms was the resistor where we had the maximum power output, which was in this case 60 milliwatts. So this was our perfect maximum power point. Let me clear the data again. So now we're trying to figure out if we can see in this setup what we just described here, that with different lighting situations you have a different maximum power point. So I'll start the recording of the data again. We can slide our resistor here. So we can see we have a maximum power point now far on the left of our graph. And now we can change the lighting situation a bit. We're moving a bit away from the sun. We use a different angle, so the power input onto the panel is different. And now we do it again. So I'm sliding here my resistor at the back. And there we can see here now is a second curve. And if we do it a bit bigger and I press the stop button, now we can see that the maximum power point slightly shifted. And that is what we want to explain our students with this setup, how it works. And this does not only apply for PV panels, but for every power source you have. You should always look that your load resistance is the same as the resistance of your power source, so that you have the maximum power that you can draw out of that power source. So as you can see here, we have the same research questions, but we have different approaches. We have in both setups a PV panel, but on the one hand, we have a lot of technology supporting us collecting the data, and on the other hand, we need to do it ourselves. So this is also meant for different entry levels of your learners. Some, they might not yet be so familiar with experimenting, with deciding which is my dependent variable, which is my independent variable, how do I have a controlled condition, what do I need to look at, and also with evaluating the data. If you use only this panel, then you need to evaluate the data yourself. You need to come up with a graph, you need to put in the data, or you need to process it via Excel or some digital tool. And here everything is done for you. So the same experimental setup, but different levels of complexity depending on your learners.